Does dark matter annihilate normal matter? Should we be searching for signs of life in other galaxies? Do we know how to terraform exoplanets? Answering all these questions and more in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops into your brain, just write it down. I'll gather them up and I will answer them here. All right, let's get into the questions. Birds Adorb. How do we know how to terraform an exoplanet? I'm going to include terraforming planets like Mars and Venus and other things in addition to us terraforming exoplanets, because we actually know more about what it might take to terraform a planet in the solar system than what it might take to terraform a planet in another solar system where, we may not have the right idea. So like what our advantage with Venus and Mars, for example, is that we understand them fairly well. At broad strokes. I mean, obviously there's a lot of small things we don't know, but at the broad strokes, we understand what their temperatures are. We understand what the chemical compositions of their atmospheres are. We understand what the chemical compositions of their surfaces are. We understand how much energy they're receiving from the star, how much they radiate back out into space, and so on and so forth, right? And then we can compare that to Earth, and we can say, okay, Earth is at 1 astronomical unit from the sun. Its atmospheric density is this. Its atmospheric composition is that. And it has liquid water on the surface, and it has an atmosphere that is thick enough for life to breathe. And we understand, there have been enough experiments done on life to understand the range of conditions that life can handle. There are like the extremophiles. So like, for example, bacteria can survive to 130 Celsius. That there are bacteria that have been found that can handle that. Bacteria can survive at negative 18 degrees Celsius as long as it's in liquid water. So liquid seawater, things like that. We know that bacteria can exist in an anaerobic environment, something that has no oxygen. We know that bacteria can survive in a high methane environment. We know that it can survive in high pressure environments that are tens, hundreds of times higher pressure than what we experience on Earth. We know that they can survive for some period through hibernation in vacuum, in high radiation environments. So you've got sort of like two versions of this. One is the extremophile. What is it going to take to change an environment that is even too hostile for extremophiles and turn it into something that they can handle? And then the sort of the deeper, the one that is probably more meaningful to us is, but how do we make it more like Earth, where life like us could walk around on the outside and breathe and not be crushed by incredible pressure? And then you just start to tinker, and I use that sort of very loosely, you start to tinker with the kinds of things that you have under your control. So you may need to decrease the amount of energy that is falling on the planet. And so you need a way to block the sunlight to the planet. Like so with Venus, you want to cool down the temperature of Venus. You're going to need to block the sunlight. So maybe you put some kind of giant sunshade that is blocking some of the sunlight until you get an amount of sunlight that sort of is nicely regulated with Venus to give you the kinds of temperatures that you want. It's not, 400 plus degrees on the surface of Venus. It's on average 10 degrees, like something closer to Earth. And then you can also think about the atmospheric density. And so on Venus, the atmospheric density is ludicrously high. The pressure is like 90 times what it is at Earth down at the surface. And so in that, you're going to need to decrease the atmospheric density. And so to do that, you're going to need to cool down the temperature of the planet to the point that the atmosphere will actually freeze out as snow. All that carbon dioxide will just fall as snow. We know that happens at, once you get significantly enough below freezing, carbon dioxide will just turn into snow. And so you'll lose that atmospheric density on Venus. So that's, you can sort of tinker in ways to decrease the atmospheric density of a planet. You can tinker with ways to increase the atmospheric density of a planet. You can, say with Mars, you can try to bring more energy, more sunlight. You can try to put in things that will raise its temperature. You can try and figure out ways to stop the loss of the gases, the atmospheric gases that are leaving. So you could, again, you could put a shade in between Mars and the sun that would stop the solar wind from taking Mars's atmosphere away. And then you can also do things like you can increase the temperature on Mars. That would cause the carbon dioxide ice sheet to melt. It would cause the water sheets to potentially melt. You could figure out ways to make more volcanic outgassing to thicken the atmosphere. And if you needed to, you could do things like crash asteroids or provide more volatiles to the surface of Mars. And so there's ways to tinker with the atmosphere. And then you can think about ways to tinker with the actual the constituents of the atmosphere. And so here on Earth, our atmosphere is oxygen and nitrogen, and on Venus it is mostly carbon dioxide with nitrogen, but in fact there's twice as much nitrogen by volume in the atmosphere of Venus than there is on Earth. And so you just need to get rid of that carbon dioxide by freezing to the surface, locking it up with some kind of mineral like magnesium or calcium, and then you need to draw down some of that nitrogen, and then you'd need to bring up the level of oxygen. And there are various ways that you can do all of these things. So really it's about what are you aiming for, knowing what you have to work with, either blocking energy coming in or increasing the amount of energy coming in, either decreasing the density of the atmosphere, increasing the density of the atmosphere, changing the composition of the atmosphere. And in theory, you will slowly over time be able to make these changes. When you think about what happened on Earth, when we had cyanobacteria evolve and start to take over, the composition of the Earth's atmosphere changed dramatically from something that didn't have a lot of oxygen in it to something that had more than 20% oxygen. And it's called the oxygen catastrophe because it was such a dramatic change to the atmosphere of Earth. But it was just something that little tiny plant bacteria were able to do. And so in theory, with our technology and over long periods of time and enough will and commitment, we should be able to make changes to various worlds. Once we find exoplanets, then we will just take that same thing. What needs to be fixed? The atmosphere, the composition, the energy that's falling onto it, and other issues. And in theory, we'll be able to approach them. But with all that being said, you've got to take a science fiction lens to everything I just said. All you got to do is you just change the temperature. All you got to do is you just change the atmosphere. Like, it is mind-bogglingly difficult for us to make a significant change to the composition of a planet, the energy budget. I mean, we are here on Earth, 8 billion people living our most carbon-rich environment, going full-scale planet terraforming Earth, and we are increasing the temperature by, a couple of degrees over the next century. That is a dramatic change for life, for our society. Like, it's going to have all kinds of implications. But when you're comparing what you might need to do to Venus or Mars, it is a drop in the bucket. And so our technology today is just insufficient for us to be able to accomplish those kinds of things. And I don't think anyone's willing to pay the price. So, we are unfortunately doing a terraforming experiment here on Earth already. And, that's going to give us a sense of the scale that will be required to actually try and do that on other worlds. Ooh, Fraser, is it possible for us to detect life in another galaxy? We are having a really hard time detecting life here in the solar system on objects that are tens of millions of kilometers away from us. Like, we argue about whether or not there's life on Mars, whether or not there's life on Venus. We don't really know how to detect life on exoplanets that are going to be tens of light years away from us, potentially hundreds of light years away from us. We have ideas, but there's no surefire thing that, this is the gas that if you see it present in the atmosphere, then that tells us that there's life there. And that is with the most powerful telescopes that we have today, as well as the most powerful telescopes that are in the works tomorrow, and for the coming decades. We're probably going to live in this land where it's inconclusive whether or not there's life on some other exoplanet until we actually go there. And so then, would we be able to detect the presence of life in another galaxy? Well, Andromeda is still 2.5 million light years away from us. Well, I mean, I guess you've got the Large Magellanic Cloud, which is closer, but still, that is a very far galaxy away from us. So on the surface, no. With our existing technology, with the technology that we can imagine in the future, you would need a telescope that is tens of thousands of kilometers across to be able to make the same kinds of observations that we could make with a 10-meter telescope observing planets that are just a few light years away. That said, the most effective way to determine whether or not there's life on a planet is to send a spacecraft. And we have sent spacecraft to Venus and to Mars. We've sent spacecraft to Jupiter, to Mercury. And in the next few hundred years, we will probably have the capacity to send a spacecraft to another star system. Now, one that is like Proxima Centauri, within a couple of light years away from us. But our technology will continue to advance and accelerate. And you can imagine this time when, and it won't be long, like within a few thousand years, say, that we are capable of sending spacecraft at relativistic velocities close to the speed of light. To other star systems. And then, so say we want to send a spacecraft that's 99.9% the speed of light to Andromeda. It's going to take us 2.5 million years to get to Andromeda, to go to a specific star system in Andromeda. And then it's going to be able to just look around with its eyes and see if it sees trees and stuff. And, you know, that seems outlandishly science fiction today, but technology marches on. And it is theoretically possible that about 6% of the entire observable universe that we can see falls within our reachable sphere. That if we that quick send a spacecraft at 99.9% the speed of light, then we can get to that amount. And that is hundreds of millions of galaxies that are within that sphere of us. And then we can build self-replicating probes that can go to each one of the planets in each one of those star systems and look around and tell us if there's life there. So is it possible for us to detect life in another galaxy? Absolutely. In that, as we build self-replicating robot probes, as we send them off fast, you know, almost as fast as the speed of light, as they reach other galaxies and make copies of themselves and dig under every nook and cranny in every single galaxy, we will get a comprehensive answer of where all of the life is in the entire reachable universe. We're just not there yet. So it's not a question of if, it's a matter of when. If you want to support the work we do at Universe Today, consider joining our Patreon club. Your support lets us have a minimum of ads and no sponsorship messages. Patrons get no ads on universetoday.com for life. Want the extra parts of the live stream that aren't in this edited version? You can sign up for a special patron-only podcast feed and get the overtime segments, as well as other special behind-the-scenes episodes, including our monthly patron-only question show. Thanks to everyone who has already subscribed, and welcome to our recent newcomers: Nathan Egan, Douglas Federoff, The Flying Dutchman, Gak, Norm Corvo, and James Long. Join the club at patreon.com/universetoday. Andrew Fish: is there any evidence that dark matter and normal matter annihilate each other? In one of your interviews, the scientist was looking for that from inside the Earth. So there is no direct evidence that dark matter and normal matter annihilate one another. And this is one of the kinds of things that people would be looking for. Like, we know that regular matter can collide. And then when matter collides, it can release energy, it can release new atoms, that it creates this imprint in the universe that we can see. And the problem, one of the sort of really difficult problems with dark matter, is that whatever it's doing out there, it is not interacting directly with either itself or regular matter in any way that is easy to note. But the theory goes that it's not necessarily about it interacting with regular matter, although that's possible. It's that if you can compress dark matter into a region that is tight enough, then the dark matter is going to interact with itself. And then that process is going to produce some kind of waste particle. Neutrinos, maybe it's going to create antimatter, and then the antimatter is going to create gamma radiation. That there should be some effect if dark matter is compressed in a tight enough place, even though normally, because normally it's just like very massive particles that are very far away from each other, and they drift past each other, and they have a very small, what's called a cross section. So the likelihood of two particles actually colliding with each other is really low. But if you collect them together, force them into a small area, and then you make them fight, then you may be able to get some kind of outcome from that. And it could be that, yeah, in a compressed area, it is actually going to interact with regular matter as well. And maybe you are going to get this release of particles, neutrinos, other kinds of energy, and so on. And it's just a matter of finding it. And so that's why people are looking for and considering places like, are there excesses of particles coming out of the center of the Earth? Are there excesses of particles that are coming from the sun because of the trapped dark matter that's inside of it. And this is like a theory that you could measure the temperature of a planet like Jupiter and know what its temperature, average surface temperature should be. But then you can say, well, but if it does have large amounts of dark matter that's trapped inside of it and it's annihilating with each other, that's going to be contributing heat. And then that's going to change the size of Jupiter. That's going to change the temperature of the surface of Jupiter. And it might be the kind of thing that's detectable. And so, right now, because we don't even know where to look for dark matter, all ideas are on the table. That it could be that we don't understand gravity at the large scales and that there is no particle. It could be that the particle is incredibly massive and slow moving. It could be that the particle is very, very lightweight and yet is very ubiquitous. Like whatever it is, we need some clues and some hints. And so that's why people are looking at it in all directions. Dougal, does the YouTube algorithm drive anything you do for the channel, or is it just at your discretion? So there is a tremendous amount of pressure from YouTube to drive the kind of content that you create, and that it is telling you the kinds of formats that work really well. It is trying to experiment with different kinds of length, like shorts and live streams and things to compete with its competitors, and it will algorithmically drive certain things. It is the second largest search engine in the world, and so a lot of value is to be gained from chasing search queries and trends and things like that. That certain kinds of content does really well, certain kinds of editing styles do really well, other kinds don't do so well. And, you've probably seen people who will start out with some kind of more generic content, but then they'll start to chase the algorithm. That the algorithm is sort of leading them along by the nose and saying, you've got to produce this amount of stuff, your videos have to be this long, you have to cover these kinds of topics. And in fact, like it's so pernicious that now YouTube has embedded this deeply inside its own creation tools. And so there is anyone who's got a YouTube account, like if you go to analytics and then you click on trends, you're going to get a list of videos that YouTube thinks are appropriate for your audience, the kinds of things that are trending in your community. And the problem is that it is 100%, I'm looking at it right now, all of the videos that YouTube is recommending that I get inspired by are AI slop. So one is CERN scientists break silence on chilling new discovery that changes everything. Too late to apologize. James Webb Telescope finds first real evidence of, it goes on. So there's it's all garbage. And this is what YouTube is suggesting that I create. Furthermore, they've added to their content channel. To the content tab, they've added a new thing called inspiration, where they will use an artificial intelligence to brainstorm ideas for videos that you can create. And what does it want? It says, build a Venus cloud city with Lego is a thing that I should make, but it also is very low interest. I should do a video about why Jupiter is the king of the planets. And there's medium interest. And then one, how do we find new planets? Very high interest. And then the story of dark matter from theory to discovery. And in theory, those are video topics that YouTube thinks that I should today be working on. And you can feel the algorithm gripping your brain, forcing your hands to, forcing you to smile to make these kinds of videos. And it can be very effective, but it is a recipe for burnout. And so what you see happen again and again and again is that YouTubers will follow the algorithm, they'll see some kind of success, and then they'll just be working harder, working faster, making stuff that is creatively soulless. That it doesn't give them any kind of return on their sort of psychological investment into this kind of content, and they just crash. And you see tons of videos where people are like, I can't do it anymore. I can't make any more videos. I'm done, right? So my strategy, much to the chagrin of my team, is to follow my curiosity, which is that I do these question shows answering questions that I think are interesting. I do interviews on topics that I am genuinely curious and interested in. And I don't care whether or not it's a celebrity, and I don't care what kind of traffic the interview is going to get. And I don't care whether or not it's going to perform well to the YouTube algorithm. It doesn't, but I don't care because it makes me happy. And then, you know, we cover news topics, and Anton generally picks the news that he thinks is going to do really well. But I'll push back if I just don't care, right? And like that, you know, and so like, for example, you don't see a lot of SpaceX coverage on this channel, or a lot of just like general rocket coverage, because I just don't care. I'm not interested. Like, a lot of these other channels are doing really well around me because they're covering the day-to-day, you know, tanks that are being deployed and rivets that are being added and launches that are being planned. And none of that interests me, and so I just don't do it. But so I may not be as successful as those other channels, but I am creatively fulfilled. I get up every day as excited to work on this company as I have for the last 25 years. And I attribute that 100% to following my own creativity, as opposed to trying to please some outside algorithm. So, so I think, kind of going back to your like original question, yeah, YouTube is trying to drive as much of the work that I do as it can, like a puppet master, and that there are benefits to people who do, but there is like misery in the end. So I do not recommend it. Would you like one more question? Well, we've got a bonus question over on Patreon. We'll put a link in the show notes so you can access it. All right, those are all the questions that we had today. Thank you, everyone who asked questions in the YouTube comments, and everybody who joined me for the live show. Now, we do this show every Monday at 5 p.m. at some point in the world, so definitely check to see when the next episode is coming out. Now, I'm going to explain this new bonus question thing in a second, but first, I'd like to thank our patrons. Thanks to Abe Kingston, Barry Lake Roofing, David Gilton, and David Matz, Dustin Cable, Greg Feely, Hudson Ward, James Clark, Jeremy Mattern, Jim Burke, Jordan Young, Josh Schultz, Michael Purcell, Paul Rohrbach, Sean Sargent, Spiderswap.io, Stephen Fondler-Melney, Thomas Ilskadron, and Vlad Shiblin, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So we did this in Space Bites, and now we're doing this in the question show, and we're going to do this in the interviews as well, which is that we are going to add some additional bonus content that's going to be available over on Patreon. And this is the exact same episode, so same normal Space Bites, same question show, same interview, but with some additional bonus content. Now, you can click on the link. We'll put it in the show notes. We'll put it in the comments. We'll make a card. We'll put it in your dreams. You can use that link, go over to Patreon, and watch the episode. And we'll put a reminder at the beginning of every episode so you can just start right away and watch it. And that has no ads, and it's completely free. You don't have to become a patron to watch these. They're publicly available. But if you want to get a notification for when we release new episodes, if you follow us on Patreon, again, completely free, then you'll get an email notification when there are new episodes. So why are we doing this? Well, the reality is that it is really hard to let people know about your content here on YouTube. And at the same time, YouTube is doubling down on AI slop videos. They're trying to push a lot of these into the algorithmic feed. And that makes more, I don't know, reality-based channels like ours slip down in the rankings against sort of AI freak you out type videos. And so we want to try and regain a little bit of control here, which is that trying to build a direct connection with you, the audience, so that you can watch these videos when we release them. And so hopefully you'll get into the habit of going over and watching our videos on Patreon instead of waiting for the YouTube algorithm to randomly show our videos against all of this other stuff. So I hope you enjoy the additional bonus content. We're going to make it worth your while. And don't forget, there's no ads. All right, we'll see you next time.